One, go.
And welcome back to Coffee with Carl. Last time we talked about the nothing box, and we also talked about the principle of inertia. Now here's the thing, when you talk about the nothing box, you're talking about human psychology perhaps. And you might think that when you're talking about the principle of inertia, you're talking about the real world outside your head. But in actual fact, how you think inside your head is then projected onto the world, and you interpret what comes in from the kinds of ideas you've had. So in actual fact, to say that inertia, or the principle of inertia, is a real description of reality, as though it was something separate, isn't really true, even though it is the way it is taught. So you go to school and they teach you, the laws of motion, they're founded on the principle of inertia. An object moving in a right line will continue to do so until a force acts on it. Well, that's what your nothing box tells you. So when you look at it in terms of science, it's got a kind of language that creates the illusion of being about the real world. So here's an example, for instance. Being in a state of motion has no different effects than being in a state of rest. In fact, I think it was Galileo who did the experiment in a ship, or thought about it in these terms, that when you're in a room in a ship and it's moving along, you can't tell whether you're moving or whether you're not moving, because uniform motion and rest are equivalent. This is the first great unification of science, and it's continued since. In other words, been looking for a way of imitating the female mind, which sees connections everywhere. And here's the male mind trying to create those connections from its nothing box perspective. So if you want to understand what inertia is outside of the science, it's a state of nothing happening until something makes it happen. And that something is called the force. So already we're moving into a technical language derived from the nothing box. And for that language to work, you need a whole lot of other words, like mass and energy and so on and so forth. But they're all derived from the principle of inertia, and they're all derived from the nothing box. So when you drop something and it goes here, there's a change of state. And this change of state must be caused by something outside of the box, so it's called a force. And to make it distinct from other forces, it's given a name. It's called gravity. So when we say that something falls, we say a force made it happen. Actually, we're not really entitled to say that, because A, the evidence isn't there yet, it's unlikely to be as well, but what you are entitled to say is that when a thing falls, gravity drops out of it as a logical conclusion. So it's what's called a valid statement. It's not actually true, it's valid in terms of the concepts that have come out of the nothing box. And to this day, it's merely been valid. It hasn't been proved. So it's a very odd thing to find when you listen to scientists. The first thing is say, well, you can't say this or you can't say that because we haven't got the evidence. Well, the firstborn of science has no evidence. So what made it such a powerful concept? Well, we've already said why. Because it was useful. Because out of those concepts, you can devise a mathematics. And that's the bit of Newton that's been kind of separated from the rest of his life. Because his whole life, let's face it, he was an alchemist more than he was a scientist. In fact, the word wasn't coined until the 19th century, but he was more interested in alchemy than he was in science. It just so happens that he had a good mathematical brain and was able to produce mathematical models. Those mathematical models are, to this day, extremely useful. In fact, when you look at anything that's going on in the world, politically or economically, It's mathematics that's behind it. When you hear a budget, for instance, those numbers aren't plucked out of the air, they're part of a mathematical model. So, how did it get so influential? You know, considering that everything else in science is supposed to be based on evidence, how is it that science itself is based on an idea that has no evidence, it has no substance? Well, you need to go backwards a bit. Now, you know, when we talk about the universe, that we're told the galaxies and the nebula and so on, that they're all rushing away and expanding and so on. This is what led to the idea of there being a Big Bang. Well, we're not going to talk about that, but it's a useful metaphor. Because how is it possible for the principle of inertia to have become so powerful? Well, this is due, well, there's no one reason, but in actual fact you can plot it back. So when we look at the origins of science, back with Galileo and onwards from there was a huge feeling of unrest. It nothing to do with science, it was much more complicated than that. But there was a feeling for a need for some kind of form of thinking that was free from the prejudices that were ruling the roost, so to speak. Some of these were religious, some of these were political, and so on. But there was a need for a knowledge that was separate from all this. And if you plot it to a particular point, you'll find that it began with a philosopher called Immanuel Kant. Now, most people who may be familiar with Kant will know that he wrote some pretty heavy tomes, Critique of Pure Reason and so on. But long before he wrote these, he wrote a very small book. It's not really that well known either, and it was called Dreams of a Spirit Seer. Now, the aim of this book was to virtually put science on the map, to put this kind of knowledge on the map. And how do you go about it? Well, you go about it in a kind of political way, in the way that people still do. If you want power, you kind of denigrate the opposition. You find some dirt to dish on them. And for Kant to have been successful, he looked around and looked for the biggest guns of the time. And one of them was a guy called Emanuel Swedenborg. And he was a scientist his whole life, pretty good scientist, as influential as Newton and others in his own time. But he picked on the fact that he was what he called a spirit seer, that later in life he moved into a different direction. Now that direction will be interesting later on. But he made a big thing of the fact that he was a spirit seer. He had his head in the clouds and so on. Actually, his objection to Swedenborg was this. Swedenborg wrote early in his 50s that there cannot be anything that corresponded to the principle of inertia. Well, this was totally against the odds of the feelings of that time. In fact, I can only think of one other philosopher who said something similar, and that was Jean-Paul Sartre. In Being and Nothingness, he wrote one short line. He said, "It's absolutely absurd to think of a self-activating universe emerging from a principle of inertia." So it was his inertia principle, or his objection to his inertia principle, that made Swedenborg the target. So when he writes about Swedenborg, actually he begins by putting the principle of inertia in philosophical terms, and then spends the rest of the book defending that one principle, because that's the principle that was to put science on the map. Now, how he did that is in itself an interesting story, and maybe that's enough to think about for this particular coffee break. So cheers, see you next time.